Okay, ellipses. So, I showed you the picture. I already talked about ellipses are these oval shapes. A little bit of definition vocabulary here. Really a lot of definition vocabulary here. First of all, an ellipse is a set of all points in a plane whose distances from two fixed points have a constant sum. Okay, so those two fixed points, if you look at the next line, the fixed points are called the foci. In other words, today we have not one focus point, but we have two focus points. And plural of focus is foci. Okay, so our parabola had a focus. My ellipse have foci, or two focuses, if that sounds right. You know. But the idea is the ellipse, so here's my two foci. The ellipse is drawn by adding, how do I want to say it? It's, as I said, it's a set of all points whose distances from two fixed points have a constant sum. Okay, so this point right here on the ellipse, well, the distance from the two foci adds to be the same as if I drew a point right here on the ellipse. Okay, it's always the same. Okay, the line through the foci is called the focal axis. So it's on the longer axis, is what I always like to say, but it goes from focus to focus. The point halfway through the focal axis is called the center. Notice it's the center, not the vertex, because where are the vertices? The points where the ellipse intersects its axes are the vertices. Okay, so you'll notice we've got a vertex at each end here of your longer axis. And speaking of that, the longest line going midway through the ellipse passing through the foci is called the major axis, whereas the shorter line going midway through the ellipse is called the minor axis. So you've got to understand we've got a major axis, which is the longer one, minor axis being the shorter one. Now, keep in mind, does my ellipse have to lie horizontally? Could that major axis be the vertical one? And it can, okay? So just like our parabolas could open up or down or left or right, my ellipses can have the major axis being the horizontal one, or the major axis could be the vertical one. Okay, so major axis, minor axis. You've got your focal axis that goes from foci to foci, or focus to focus. Center is in the middle, and your vertices are at the ends of the major axis. Okay, and that focal axis lays on the major axis. Okay, refer to that list of vocabulary. When I give you, 99% sure here, when I give you at test time a list of formulas and stuff, I'm including this part up here that has all the definitions. Okay, that way there's no question about definitions. Now, I don't know if you guys have flipped from front to back on this ellipse page, but we have two charts with ellipses. If you want to get technical, we could just have one chart. Our chart on the front is ellipses with center 0, 0. Our chart on the back are ellipses with center H and K. So the ones we're working at first are ellipses that are centered at the origin, at 0, 0. When we flip over to the back side, they're going to be ellipses that are shifted, left, right, up, down. In other words, they have some vertex other than the center. Okay, so check out your standard equations here. Definitely a little bit different form. Okay, when we write standard equations, that's what we're going to be looking for. Notice I have a left column and a right column again, yes, or first column and second column. This first column goes with when my major axis is the horizontal axis. Second column goes with when my major axis is my vertical axis. Okay. Notice the difference in the equations really here is that x squared is over a squared, y squared over b squared, whereas here it's x squared is over b squared, y squared is over a squared. Notice they're always adding. Notice they always equal 1. Talks about where your focal axis are, your foci, your vertices, major axis and minor axis. Notice they're always 2a and 2b. And then we have something called Pythagorean relationships. Okay, the Pythagorean relationship for an ellipse is c squared equals a squared minus b squared. And what it is it's how A, B, and C are connected. You understand why it's a Pythagorean relationship, right? It's very similar to Pythagorean theorem, but not identical. Okay? It's related, but not the same. So c squared equals a squared minus b squared. Like yesterday, I'll draw pictures some. Some of them you are going to have to draw pictures for to see. Some of them you aren't. It really varies from person to person. So let's look at example 1. This time they're giving me an equation. Find the vertices and the foci of the ellipse 4x squared plus 9y squared equals 36. So 2 questions here. Vertices and foci. Well, take a peek here. If we're talking vertices and foci, what do we have to know? And we haven't even talked about whether this is a horizontal ellipse or a vertical ellipse, right? But we're going to, either way, whether to know our foci and our vertices, we're going to have to know A and C, yes? Well, notice C isn't even in the equation. We'll talk about that in a moment. But in order to find A, we first have to get our equation in standard form. Okay? So what it becomes, standard form has to equal 1. How do I get this equation here to equal 1? What'd you say? I agree subtracting 35 would make it equal 1. However, if you look up here at the standard forms, there's no really place for a minus 35 to be. What's another way to make it equal 1? How else do we make a 36 become a 1 besides subtracting 35? What? Okay, or how about we just divide by 36? Okay. And I see what you're connecting to, so we'll get there in a moment. So the idea here is we already have an x squared term plus a y squared term. To make this 36 become a 1, I'm going to divide by 36. Now, if I divide the right side of the equation by 36, we're dividing everybody by 36. Now, cleanup is important here. What do you know about 4x squared over 36? What do you know about 4 36ths? 1/9. So what is 4x squared over 36? Or I'm going to write it as x squared over 9. So what do you know about 9y squared over 36? Y squared over 4, because 9 over 36 is a fraction that reduces, right? 9 over 36 reduces to 1/4. So this is y squared over 4. And 36 divided by 36 is 1. Now, we need to decide, is this a left column or right column ellipse? And the question is, how do we decide that? Okay. If you look up in your pictures about A versus B, notice A is always on the major axis, yes? And so if you notice where A is in relation to B in both pictures, A is always going to be bigger than B. Okay, so if A is bigger than B, in order to decide which this is, the bigger number in the denominator is A. So where is my bigger number? My bigger number is under the X. So what that's telling me is that this is a left column problem and that my major axis is going to be the X axis. Okay, and that's because the bigger number is under x squared. So when we think about this problem, this is x squared over a squared plus y squared over b squared equals 1. This is a left column problem, if you would. Have I sold everybody of why it is the left column? Because you have to be sold on that and understanding of that. And it's all because the bigger number is under x, so that means x, that's the a value, or the a squared value. Now, before I move on, I'm going to rewrite this, because notice, standard form is x squared over a squared and y squared over b squared. Do I have a squared and b squared right now? I mean, I do and I don't. How could I rewrite 9? 9 is equivalent to 3 squared, yes? How can I rewrite 4? 2 squared. So I'm going to rewrite this as x squared over 3 squared plus y squared over 2 squared equals 1. And by doing that, I just identified my a and b. What's a? 3. Because x squared is over the a, or a is always the bigger number, okay? A is the bigger number here, and in that case, and it's the square root of the whole thing, so a is 3. What's b? B is the smaller of the two, and so b is 2. Notice I'm not using 9 and 4, because it's a squared and b squared. Now, okay, what did they ask me to find? Vertices and foci. How do I find vertices and foci? Where am I going to look? Go logically here. What's up above you guys? We're in which column? The left column. What's it say about vertices? Okay. Plus or minus a, comma 0. What's it say about foci? Plus or minus c, comma 0. Hello? I do. Okay, I will send it in. Emily, I will not get through all the notes today, so you're welcome to go ahead and start on the homework, but I'm not going to get through everything, so. Okay, are you guys okay with the fact that I wrote down vertices are plus or minus a0 and foci are plus or minus c0? Okay, can you tell me your vertices? -3, 3, 0? Because what is A? A is 3. So my vertices, and you can actually write plus or minus 3, 0. That would be equivalent to writing 3, 0, or 3, comma 0 and -3, comma 0. Okay. What are my foci? Are you guys processing what he said? He said we have to do the Pythagorean relationship. Do we have a c in this equation? No. I have x squared over a squared, y squared over b squared, and it equals 1. I don't have a c, but I need to know a c to find my foci. We have a that we just used, and what else do we have? B. Pythagorean relationship? C squared equals a squared minus b squared? Let's go for it. So, c squared is equal to what? 3 squared minus 2 squared? 9 minus 4, which is 5. So if c squared is 5, what's c? Square root of 5. So what are my foci? Plus or minus square root of 5, comma 0. Now, did we have to draw anything on that one? No, not at all. I'm definitely going to do some drawing because you've got to learn how to draw an ellipse and all the different details that go into it. But that one, they gave us the equation. It was just about doing the algebra behind it. Questions on that one? You got what you need on that one? I don't think of it as difficult. However, when you have to go back and do it on your own, you may disagree with me. Just because the first time doing it on your own is going, that's the challenge. It's not a difficult problem. It's figuring out how to do it on your own, though, that's the difficult part. Okay, let's try equation 2 then. Or problem 2, I mean. This time we're being asked to find an equation. Find an equation of the ellipse with, what are they giving me? Foci, 0, -3, and 0, 3, whose minor axis has length 4. And then it says, sketch the ellipse. Okay. So, you have that chart of information above you, right? Or above the problem. We have to figure out what information are they giving me. What are they giving me there? I heard C and B. Okay, let's make sense of that. How do I know C? Someone said they're giving me C. Okay, it gives me foci. Go up in the chart. What's it say about foci? Well, if you're in the left column, foci are plus or minus C0. If you're in the right column, foci are 0 plus or minus C. So, which ones are these? Yeah. This is 0 plus or minus C. And so that means C is 3. Besides telling me that C is 3, because those are my because that's what foci tells me, it also tells me, I heard someone say that this is a right column problem. So that means this ellipse is going to be vertical. Now, because I have to write an equation, I'm going to go ahead and write down my form. So this is going to be y squared over a squared plus x squared over b squared equals 1. So eventually, sorry, I'm off the screen there. That's what I'm going to be filling in to write my equation. And I know that because in my foci, the C values are in the second spot in the ordered pair. Okay, so we decided it was a right column problem because of where C is located in the foci. Someone said we know B. Okay, wait, hold on. How do I know B first? Okay. Are we okay with that? Minor axis has length 4. What's it say up there about minor axis? Minor axis is 2B. So if 2B is 4, then our brilliant algebra skills tell us B is 2. Okay. Now, you start talking about being centered at 0, 0. What were you going to say there?
No, I didn't see the minor axis formula thing. I was just thinking this was 0, 0. Yeah, like 4.
Okay, I see what you're saying. Ah. Okay. So I cut you off too soon. I should have heard you out is what it comes to, but I got it. I was just, okay, minor axis, it says 2B equals 4. He was going with minor axis, since we know it's centered at 0, 0. If it has a length of 4, then that means the minor axis goes 2 each way. I got it. Okay. So you're supposed to write this equation. What else do I need to know to write the equation? These are questions you should be asking yourself. What else do I need to know to write the equation? We're missing A. Okay, guys, you know how to do this. How do I find A? Don't we already have a B and a C? And when it comes down to, guys, whether it's ellipses right now, or when we get to hyperbolas, it's going to be the same thing. A, B, and C. If you know two of the three, you can always find the third. Okay? So my Pythagorean relationship, C squared equals A squared minus B squared. So 3 squared equals A squared minus 2 squared. Do the math. So if A squared is 13, what do we know? A is the square root of 13. That was algebra skills there. Are we up? Okay. You can say plus or minus here, but in this situation, we really just think plus. Because A is that length on the, on the ellipse. It's the length from the center out to the vertice. And so we don't usually write plus or minus here. When we plug it into the equation, our equations already have a plus or minus there. So now, can you write your equation now? Okay. And don't forget, leave room to somewhere to do a drawing. My drawing's going to end up in the middle, the way mine's set up. Okay. Y squared over A squared is going to be Y squared over square root of 13 squared. But what is the square root of 13 squared? 13. So what I would probably do is write it as Y squared over 13. Just depends. It'd be okay either way. X squared over B squared. So that's going to be X squared over 2 squared, or in other words, X squared over 4. And it equals 1. Okay. Are we ready to draw it? Now, we are only dealing with an ellipse centered at 0, 0 right now. Okay, so we don't have to worry about anything fancy there. Okay, so first ellipse we've drawn, right? If you look back up at your picture, first of all, remember, which column problem was this? This is a right column, yes? When you look at this, okay, it was a right column problem, which means what? My bigger value ended up underneath the y. That means on the y-axis, we are going to count out farther. What was the a value? It was the square root of 13. What is the square root of 13? I have written down that the square root of 13 is approximately 3.6. Okay. If the square root of 13 is approximately 3.6, because 13 is under the y, that means on the y-axis, we have to count up square root of 13 and down square root of 13, because that's my a value. And notice, right here, guys, what's the a value doing? It's marking my vertices. Okay, so I'm going to go up to 3.6 and down to 3.6. I'm kind of going to label them A here, so when you look back at this later, you can figure out what I did. Now, what's B? B is 2. B is the smaller number. B is under my x in my equation. So since B is under my x, that means on the x-axis, the horizontal axis, I'm going to go out 2 both ways. So that means I'm going right 2 and left 2. And those are my B values. Okay, that's on the minor axis. Now, officially, that's all you need to draw, actually draw the physical ellipse. It goes through those 4 points, your 2A values and your 2B values. I do not make the best ellipses. I have troubles drawing them, but. Now, the one thing I did not put in, okay, to draw an official ellipse, we really need to put our foci in. Foci are represented by what letter? C. And foci are always on the major axis, so they're always on the same axis as A. What was my C value? It was 3, so that means we're going up 3 and down 3 for our C value. And so those foci are always inside the vertices. And your foci are just, the ellipse does not go through them or anything. They are just points on that major axis. Okay, questions on that page? I'm going to flip to the next page and kind of start talking about it here. What's the difference on the chart we're going to look at on this page? Instead of being centered at 0, 0, these ellipses are centered at, okay, wherever, HK. So a lot of stuff is the same as the front page, except you have an H or a K mixed in. Okay, standard equation, okay. On this one, if it's horizontally longer, your A value, the bigger value, is still under the X. If it's vertically taller, that means the Y value is bigger. A is under the Y. Okay. You've got all the same information, or similar information for focal axis, foci, and vertices. Notice, major axis, minor axis, Pythagorean relationship. Do they change? They don't change a bit. Okay. We're also going to talk about eccentricity. Okay. The eccentricity of an ellipse. They give us a formula there. I like to use E equals C over A. That other part, the square root of A squared minus B squared, that's just a way to find, that's how you find C. Okay? And eccentricity, it's always a number between 0 and 1 when it's the ellipse, and it's showing how elongated the ellipse is. So whether it's very long and skinny or whether it's closer to being like a circle. So the larger E is, the more elongated the ellipse is. So we will do a couple of examples with that tomorrow. You are welcome to start your homework and start looking at the ones that are at 0, 0, which would be the first few in homework. And then we will pick up tomorrow. Okay? I don't know what 7 through 10 is, but 2, 4, and 6 you would be able to do. And it kind of looks like 22, 24, 26, to 28 you could do. And 30. So, you can possibly do up through 30-ish. So,